looking at the 2018 AB free response number 2. You're given a relatively ugly function for velocity. First thing I would do, because this is a calculator question, I would store that in my calculator for f1 of x. We will use our calculator quite a bit on this one. Around the interval 0 to 3.5, I would also go ahead and change my window, my graphing window, to that, so I can focus on the important parts, the parts I need. Then they tell you the particle is at position x equals 5 at t equals 0. I would prefer to see that as my x position at time 0 is -5. And then we start answering questions. Part A, find the acceleration of the unit at time t equals 3. Very easy question, as long as you remember that acceleration is the derivative of velocity. And so the acceleration at time 3 is just going to be the derivative of velocity at time 3. Throw that in the calculator, use the derivative at a point command, or if you have a TI-84, the n-derive command, or whatever equivalent to those your calculator uses. The one thing that we do not have in this problem is units. So if you look up here, it just says we're traveling along the x-axis. They don't tell you if t is measured in any particular time unit. So because units are not provided, I'm not going to worry about units. However, you should know that acceleration is measured in units squared. No, it's not. It's units per whatever the time value is squared. And I'm just going to put that kind of in a thought cloud because it's not really part of my answer, but I'm just putting that there to remind you that units for acceleration would be like feet per second squared or something along those lines. Find the position at time t equals 3. So part B is asking for x of 3. And the way we will do that, because we're given velocity to get to position, I'm going to have to do the antiderivative of velocity, but they purposefully gave you a function that does not have an antiderivative in the world of elementary functions, which is what we're using in AP calculus. If you tried to punch that antiderivative in the calculator, it will spit it back at you. It will not give you an antiderivative, but it can do a definite integral, and that's exactly how you set this up. We know my initial position at t equals 0, so what I'm going to do is measure my velocity graph, or my velocity function, from 0 to 3. And this integral, the antiderivative of velocity, tells you the net change. So if you know how far you move on 0 to 3 and you know where you started, you can throw that in the calculator. And this one, I just punched it in my calculator a second ago, gives you a position of -1.760. So we had a overall change of moving to the right. There could have been some back and forth in there. Do remember that answers must be accurate to the third decimal. If you write -1.76, you lose, because that does not indicate that you know that the third decimal is a 0. So even though this is not really significant digits as far as science is concerned, that third decimal is important on the AP Calculus exam. So make sure that you do include that third decimal. Let's see. So these two are going to be kind of quick because you really just throw them in the calculator. So I'm just going to unveil the problem here. So we're going to evaluate these two integrals, 0 to 3.5 of v and 0 to 3.5 of the absolute value of v. And both of those, you're just going to throw in the calculator and write down the answers. Again, make sure you're accurate to the third decimal. If you look at this top one, the integral of v of t, your fourth decimal was a 9. And so that one, they would actually accept 2.844, which is standard rounding procedures. They also would accept what's called the truncated version, which just means you stop writing after that third decimal. They are both acceptable. If you're worried about which one to choose, then just write the fourth digit. It really doesn't matter. They would accept that as well. So as far as the interpretations, now here we are interpreting the integral, not necessarily the answer. And I just realized that I did interpret the answers. If you look at the first one, the integral from 0 to 3.5 of v is your displacement. It's your net change in distance, not the total change, but your net change. And so I wrote that this is the displacement, or the net change in distance traveled, from 0 to 3.5 is that many units. You always want to, when you're interpreting integrals, when you're interpreting answers, you want to restate everything. And so you must restate the interval. I wrote from t equals 0 to t equals 3.5. You could have done it in interval notation or something like that. What was not necessary, and this is what I just realized a minute ago, is they asked you to interpret the meaning of each integral, not necessarily the answer. So the answer, or the units, the actual answer, is not exactly needed. However, it's not wrong. So the displacement is what the first one tells you. The second one, when you do the absolute value velocity, that measures the total distance traveled. Again, restate the interval. And I did include the answer because I forgot that they did not ask you to interpret the meaning of the answer. And one thing I don't like about this problem is usually when you are interpreting meanings, units are provided. And so it kind of bugged me that we were measuring distance, but we don't have the feet or meters or miles or whatever. So I did throw units in here, but it's not needed. So let's see, second particle is given by this function. Now that's position, pay attention to that. And they ask at what time are the two particles moving with the same velocity. So first thing I'm going to have to do is find the velocity of particle 2. And this is an easy derivative. That'll just be 2t minus 1. And if you know that the velocity of the second one is 2t minus 1, we want it to equal the velocity of the first one. And so anytime you are going to solve an equation in the calculator, which we will, you absolutely must write down the equation that you are solving. We are setting the velocity of my second particle equal to the original velocity. I solved that graphically. Again, we had that situation where you had a 0 for my third decimal. You must write that down. If you do not write, so if you left this part out and you only included the answer, you're not going to get your point because you didn't show the setup that led to that answer. Anytime you introduce new numbers to a problem, you have to show the mathematical operation or the setup that yielded, that's a dumb word, it should be yelled, whatever, that yielded that answer. So there are your answers for the 2018 number 2 from the AB exam.